All right. You ever wonder about the magic that's happening inside your phone, or your email, or even your favorite streaming service? Well, today, we're going to pull back the curtain on all of it. We're going to demystify machine learning and show you the secret recipe that basically powers our entire modern world. Let's get into it.
So let's start with a really simple question. How does your phone do that? How does it unlock just by looking at your face, and not your friend's face or your siblings? I mean, there isn't a team of tiny artists inside your phone, right? The answer, of course, is machine learning. And it works in a way that's, well, it's probably totally different from what you're thinking.
See, for decades, the way we program computers was by giving them explicit rules, really specific instructions. Think about a simple password check, right? It's just, if the text you typed matches the password we have stored, then unlock. Super direct, super clear. But machine learning, it completely flips that on its head. Instead of us writing the rules, we just show the computer a ton of examples, and we let it figure out the rules all by itself. Okay, so here's the official kind of textbook definition. It sounds a little academic, I know. Algorithms that improve their performance automatically through experience and by the use of data. But forget the jargon for a second. Just think about it like this. It's like learning to catch a ball, right? Nobody hands you a bunch of physics equations for gravity and trajectory. You just try, you miss, you adjust. And with every single attempt, every new piece of data, you get just a little bit better. That's the core idea right there.
So how does this whole thing actually work? Well, the best way to think about it is like cooking. Seriously. We're not just, throwing stuff in a pot and hoping something good comes out. There's a recipe. And that recipe has 3 absolutely key ingredients.
Okay, so what are they? First, you've got your ingredients. That's your data. Second, you need the actual recipe, the instructions. We call that the model. And third, you need the chef, the person who follows the recipe, tastes it, and keeps tweaking it to make it perfect. That's your algorithm. So, data, model, algorithm. Let's break each one down.
All right, ingredient number 1, data. You got to understand this is the absolute fuel for any machine learning system. Without data, you've got nothing. It's just a huge collection of examples. So if we're talking about houses, each example would be a list of its features, right? Like its square footage, how many bedrooms it has, its location, you get the idea. This is the raw material the machine is going to learn from.
Next up, we have the model. This is our recipe. At its core, it's really just a mathematical simplification of reality. It's a guess about how the world works. There's a famous saying, all models are wrong, but some are useful. And that's exactly it. It's never a perfect copy. Think of it like a map. A map isn't the actual territory, but it's a super useful simplification. So the model takes in our data, the ingredients, and it spits out a prediction.
And finally, we get to the star of the show, the algorithm. This is our chef. The algorithm is the part that does all the work. It's the active process that actually does the learning. It looks at the data, it looks at the model's predictions, and it figures out how good or bad they are. And then it adjusts or tunes the model's little internal knobs to try and make those predictions more and more accurate over time. Okay, so we've got our ingredients, we've got our recipe, and we've got our chef. Now for the big question. How does the cooking actually happen? What does the learning part of machine learning actually look like in practice? Well, the most common way it's done is something called supervised learning. And honestly, the best way to think about it is like you're studying for a test with flashcards. On one side of the card, you've got the question, and on the back, you've got the answer. The machine gets to see both over and over until it starts to learn the relationship between them.
So let's stick with a classic example, predicting house prices. We feed our system a massive data set of houses. So for every single house, it gets a flashcard. The question on the front is the house's size, maybe in square feet. And the answer on the back is what it actually sold for, the real price.
Now this is where it gets really interesting. The model has to start somewhere, right? So it makes its first guess. It basically just draws a simple line through all that data, trying to find some kind of trend. And that first guess, it's almost guaranteed to be terrible. It's going to be way off, but that's okay. In fact, that's the whole point.
So how does it know it's wrong? We use something called a loss function, and you can just think of this as a score for how wrong the model's prediction is. It literally measures the gap between the model's guess and the actual right answer. So a really high loss score, that's bad. The goal is to get that score as low as possible, as close to 0 as you can. And this is where the magic really happens. The algorithm, our chef, sees that high loss score and basically says, nope, that's not right. So it makes a tiny adjustment to the model's line, just nudges it a little bit. Then it checks the score again. Is it better? Is it worse? And it just repeats this process over and over and over. We're talking thousands, sometimes millions of times. Each time it's just trying to lower that loss score until it finds the absolute best possible fit for the data. That's learning. Okay, but this brings up a really important question, right? If the model has seen all the answers on the flashcards, how do we know it has actually learned the concept? How do we know it hasn't just memorized the answers? I mean, that's not real learning. This is where the final exam comes in.
The way we solve this is pretty clever. We split up our data. The biggest chunk is the training data. This is the practice quiz. It's open book. The model gets to see all the answers and learn from them. But we hold back a small, separate chunk. That's the test data. This is the final exam. It's full of new questions, new houses that the model has never, ever seen before. How well it does on this test data, that's the true measure of what it actually knows.
So now we have the fundamental recipe, right? Data, model, and algorithm. So what else can we cook with this thing? Because it turns out this simple idea is unbelievably powerful.
I mean, it's not just for predicting numbers like house prices. This exact same recipe can be used to predict a category. Think about it. Is this email spam or not spam? It can be used to filter those unwanted emails or detect faces in all your photos. It can even be used to predict incredibly complex systems like the weather or find hidden patterns in data that a human being would just never, ever spot. It's amazing.
So look, if you take away just one thing from all of this, let it be this. The whole core idea of machine learning isn't about us trying to write the rules. It's about letting the machine learn the rules for itself, straight from the data.
So you see, the secret recipe, it isn't really a secret at all. It's just a whole new way of thinking about how to solve problems. So now that you know the ingredients, you know the recipe, what would you teach a machine to do?